Okay, so I will be doing Prairie Math League round number 126. There's a lot of requests for number 6 because this question is pretty hard. And yeah, so you need some advanced math tools, but you can feel free to try it out yourself. But likely you will need some more advanced math tools. Okay, so let's read the questions first. The area of this triangle, which is this triangle ABC, is 1/4. And the circumcircle, okay, so a circumcircle is basically a circle where all your vertices are in the circle. Okay, so for example, the 3 vertices of this triangle ABC is A, B, and C. They're all on this circle. So that would be a circumcircle. Okay, so the circumcircle has a radius of 1. Okay, so this is 1. Okay, so this is the center, obviously. Yeah, so they have a radius of 1. And A, B, and C represent the side lengths. Yeah, so this is A, B, and C. Doesn't matter. It doesn't have to look like this. This is just a diagram, not drawn to scale. But anyways, we are given S is equal to this thing, and T is equal to this thing. So if you can see it very well, S is equal to square root of A plus square root of B plus square root of C, and T is equal to 1 over A, 1 over B, and 1 over B plus 1 over C. Okay, so we're asking, okay, which one's bigger? So there's some formulas that you should know. I will give you the formulas first, and then I will try to prove this formula number 1. So the formula number 1 is A squared. Okay, this doesn't have to be inside the triangle. This A can be literally any number, and it will work in this inequality. Okay. So A squared plus B squared plus C squared is actually greater or equal to AB plus BC plus AC. This is always true. Your A, B, and C have to be anything. They don't have to be a pair of a triplet of triangle sides. And number 2 is, okay, this one you have to be in triangle. So this is just a loss sign. A divided by sine A is equal to B divided by sine D is equal to C divided by sine C. And this is what the teachers in pre-calculus 30 doesn't teach you. This is equal to 2r, where r is the radius of the circumcircle. So in this case, it will be 1. But anyways, that is the formula. Okay, so formula number 3 is the area formula, which is 1/2 sine C times AB. That is equal to area, which is equal to 1/4 in this case. And this is equal to 2 in this case, because we know the radius is 1. So that's just something to think about. Here's more. That's just your hint. Okay, but anyways, these 3 are the formulas. So with these tools, maybe you can figure this out yourself. Okay, so you can pause the video here. I would recommend you figuring this out yourself. But here's the interesting part. Actually, let's first prove this inequality. Okay, so this is usually like most of the time you don't need the equal sign here. As long as A is not equal to B, wait a second, this is not a good way to explain. As long as if A is equal to B and it's also equal to C, then these two sides will be equal to each other. But as long as this is not the case, then you don't need the equal sign here. Okay, as long as one of a pair of these two ABCs are different, then this is always the left hand side are always greater. So that is the full formula. Okay, so how are we going to prove this? Okay, I'll start off by writing a random expression. Again, A and B. Let's use A and B like for this scenario because we know that A is not equal to B and it's not equal to C at the same time. So we can erase this equal sign over here. Okay, I will make a follow-up video if you're not sure why A, B, and C are not the same. So basically I'm saying this can't be an equilateral triangle, or else the area is not big enough and not small enough to be 1/4. Because if A, B, and C have to are the same, then this area will be too big, and you can try to prove that on your own. So it's pretty obvious, actually. Okay, let's just start off by writing a seemingly random expression. And you'll see a lot of similarities between this thing and this thing. Okay, so this is always greater than 0 as long as one of these three terms are bigger than 0. And none of these three terms could be negative because you're taking them to the square. So if it was negative, then it would then you take the square of that, that would be positive. And if it's already positive, then the positive square is also positive. So this thing is definitely bigger than 0. Assume they're not equal to each other. Okay, now let's expand this. So a squared minus 2ab plus b squared plus b squared plus, not plus, minus 2bc plus c squared. Okay, so this is 2 over here. Plus c squared plus c squared minus 2ac plus a squared. This is equal to 0 because we can see from here this is greater than 0. Now let's rewrite this. So let's combine a squared and a squared into 2a squared. So 2a squared plus, okay, again, combine these two things, 2b squared, and then these two things, so 2c squared. Okay, so minus 2ab minus 2bc minus 2ac greater than 0. Okay, so let's divide each side by 2. So like, let's divide both sides by 2. 0 divided by 2 is still 0, but if we divide by 2 on this side, the two coefficients are gone. Okay, so we still have the minus though. Okay, so yeah. Now you can basically see how I got there. You just move these three terms to the other side to get this, and these three things are already here. So you see. this formula number one's true. Okay, so but anyways, so after this proof, we can start working on the actual questions. Okay, so let's first use formula number 2 and 3. Let's combine them together. Okay, so this is equal to 2, right? Because the radius is 1, so this is equal to 2. This is equal to 1/4. It literally says that right here. The area is equal to 1/4. Okay, now let's combine these two formulas. So we have c divided by sine c is equal to 2. And 1/2 sine c a b is equal to 1/4. Okay, so from this thing, we can tell that 1/2, I don't know, actually, sine c is equal to, let's multiply 2 on each side. So that's 2, and then divide by AB on each side. So 2 divided by 4 AB, because we divide by AB on each side. So let's substitute this in here. Let's use that instead of sine c, because question didn't mention like angles anywhere, so we don't want a sine c, just and we don't want the sine c. We're going to replace that with a and b. Okay, so c divided by 2 over 4 a b. This is equal to okay, so the 4ab flip up to the top, so that's 2abc. This is also equal to 2, remember. It's equal to 2, so abc is equal to 1. Okay, so we got our first conclusion, basically, and that is abc is equal to 1. Okay, now how can we use this to the full advantage? Okay, so we will need to use this, definitely. Okay, so let's start. Let's first change t to something else. Let's change t to something else. So t is equal. Let's give them a common denominator. T is equal to abc. Let's multiply this by bc, and then multiply here by bc. So we would get abc divided by bc plus abc divided by ac, abc, ab. Okay, so we know this is 1. Let's just erase these things. We know that they're 1. Okay, so let's erase them. We don't need them. Okay, so instead of writing them like this, I actually want to change them just slightly. So let's do bc squared. Actually, the square root of bc squared plus the square root of ac squared plus the square root of ab squared. Now let's just apply them to the formula. So instead of like a, it would be bc squared. So we're just, okay, remember, we're just using formula number 1. We are just plugging in formula number 1. Actually, this is a bit confusing, so I'm gonna rewrite formula number 1. Okay, so instead of writing ABC, I'm gonna write X, Y, and Z. X, Y, and Z. Okay, so What would x be? X would just be this thing. Y would be this thing, and Z would be this thing. Okay, so good. So um, let's see what we'll end up with. So this thing is bigger than just using the formula. This is X, this is Y, this is the X, which is this thing, times Y, which is this thing. Okay, X times that, X is this thing. Yeah, because we're, okay, so I should add parentheses here to show you that they're X, Y, and Z. So X squared plus Y, so they match each other, right? So X Z is equal to this thing times this thing, which is square root of BC times square root of AB plus square root of AC times square root of AB. Okay, so we're 100% sure that this is true. Okay, so now what do we do? Okay, so let's rewrite this. So this becomes C. Actually, I'm jumping a step. So ABC squared plus ACB squared plus CBA squared. So instead of writing A squared here, let's just okay, it's not factoring out, but like let's just take this out into the coefficients. Wait, actually, no, you don't want to do that. Never mind. Uh, instead of taking them out to the front, let's let's just expand them. ABC times C, the square root of C. Instead of writing C squared, let's take out a square root of C from this thing. So you will be seeing a pattern. Or another way to do it is, I guess, like you just change this to C because you already know A times B plus times C is equal to 1. So that's one way you can do it. But anyways, this one is similar. A times B times C, that's 1. Square root of 1, that's 1. Square root of 1, that's also 1. Square root of 1, that's also 1. Oh wait, there's the square root here. And okay, wait a second. Square root of C plus square root of B plus square root of A. That's this thing is literally S. This thing is literally S. Wait a second. I think we proved it. Okay, so S T is greater than S. I think the answer is B. Wait a second. Oh wait, no. The answer is okay, and the answer is C. Okay, but anyways, doesn't matter. Um, as long as you know how we got there. So the answer is C. And actually, I'm just gonna prove why A is not equal to B. There's A, B, and C are not equilateral triangle. I'm just gonna prove it like really quick. So if A, B, and C are equilateral triangles, so instead of writing A, B, and C, let's just write A, and A since they have the same length. So why not? Okay, what is the area for equilateral triangle? Okay, so this is there's a formula actually. But anyways, the formula. Okay, so the formula is square root 3/4 A squared. That's the area. This is the area. So if you think A is equal to B is equal to C, then you're saying that 1/4 is equal to this thing, right? Then A would be the square root of 1 the square of 3. But that's not going to happen. Like, that's way too small. Okay? Because, okay, so that's not big enough for a circumcenter. Like, for a circumcenter, this is not gonna do it. Okay. Like, okay. So okay, whatever. If there's an equilateral triangle here, the distance from the center, which is the center of the equilateral triangle, to one of its vertices would be 1. This is like smaller than 1. So there's like, so the side length is even smaller than 1. Then obviously this is going to be smaller than 1. But this is 1 because that is the radius of your circumcircle. So there's no way this is true. Okay, I'm just telling you. There's no way this is true. Okay. But anyways, I can calculate the exact distance of this, but just know it's way smaller than 1. When it's supposed to be 1. If this is an equilateral triangle. So anyways, so yeah, that's the video. It is pretty hard, like difficulty wise. But anyways, yeah. See you in the next video.